Hey everybody, so this video is going to be all about solving absolute value inequalities. Before we get into this, if you do not completely understand solving compound inequalities, which was the last section that we went over, uh, I would stop this video right now and go back and watch or rewatch the video that I made over solving compound inequalities. I'll put the link in the description. We use compound inequalities while solving absolute value inequalities. So you need that information or it's going to be a lot harder to understand this lesson. All right, that being said, let's go. Also, before we get into actually solving absolute value inequalities, need to make sure we remember what exactly an absolute value, what exactly that even means. So, as we previously learned, absolute value tells you how far away a number is from zero. So, all absolute value is telling you is how far the number is from zero. So, absolute value is really measuring distance from zero. And as you know, you cannot have a negative distance. You would never say, I live -1 miles from the school. You would just say -1 mile. You would never describe distance as a negative. So, same thing here with absolute value. So the absolute value of -3, which when you see that, it's going to look like this, the -3 with these two lines on either side of it. The absolute value of -3 is 3. So here's -3 down here. All absolute value is asking you is how far is this from 0? So 1, 2, 3 spots from 0. So the absolute value of -3 is 3. The absolute value of +3 is also 3. Again, it's 1, 2, 3 spots from 0. So whether it's -3 or 3, the absolute value of both of those is 3. Both are 3 spaces from 0. The absolute value of -2 is 2. The absolute value of +2 is also 2. Again, we're just counting how many spaces each number is from 0. All right, so let's see how this plays into inequalities. So when we are given the inequality, the absolute value of x is less than 3. What we're saying here is that x can be any number that is less than 3 spaces from 0. X has to be between -3 and 3 on our number line because the absolute value of anything over -3 but less than +3 is going to be less than 3. So x can be -2, it could be 1, it could be 0, it could be +1, it could be +2. This is represented by what we call an AND compound inequality. Again, if you don't remember what AND compound inequality means, you need to go back and watch that other video. It will be shown in this compound inequality where -3 is less than x, which is less than 3. So this means that x is greater than -3 and less than 3. If we put that on a graph, this is what it's going to look like. Since it's just a great or less than sign here, it's not less than or equal to, it's just less than. It's an open circle. This one, same thing, it's going to be an open circle. And those are going to go on our low number and our high number, and the line is going to connect in the middle. So what this graph means is that x could be any number that is along this line. Any number that's greater than -3 but less than 3 will have an absolute value that's less than 3. All right, so the flip side of that, if we're given the inequality, the absolute value of x is greater than 3. So on this one, it was less than 3. Here, we're saying the absolute value is greater than 3. This means that the x can be any number that is greater than 3 spaces from 0. So any number that its absolute value is greater than 3. So it has more than 3 spaces from 0. X has to be less than -3 or greater than +3. This is represented by an OR compound inequality, and this is what that will look like. x is less than negative 3 or x is greater than 3. So any number that is to the left of negative 3 or lower than negative 3, or any number that's to the right of positive 3 or greater than 3 is going to be a possible value of x. This is going to be represented by a graph that looks like this, with the arrows pointing in opposite directions from the two numbers that are given. So remember, this one, so if the absolute value is less than 3, it's going to be an AND compound inequality with the line connecting the two dots. If it's the absolute value is greater than the number, it's going to be an OR inequality with the two arrows pointing in opposite directions. All right, so that was the simple part. Now we actually have to do a little math and solve an equation. So this is a one-step inequality, but we have absolute value signs. So we are given the inequality x plus 9. The absolute value of x plus 9 is greater than 3. By the way, every one of the examples that I'm using in these notes is a question that is on your homework, the 2.6 on Big Ideas Math. So make sure you are filling those out while you are watching this. So given the inequality, the absolute value of x plus 9 is greater than 3. This means that x plus 9 can be any number that is greater than 3 spaces from 0. So it has to be greater than 3 or less than negative 3. Again, just to pop back to this one, if the absolute value sign is greater than the number, it's going to be an OR compound inequality with the arrows pointing in opposite directions. So on this one, we see the same thing. The absolute value is greater than the number. So this is what we'll end up with. So we are going to write this out as two separate inequalities. So if you remember back to chapter 1, we talked about solving absolute value equations, and we had to do the same thing. We had to split the equation up into two separate equations, with one being positive, one being negative. So we're going to do the same thing here. We separate it into x plus 9 is greater than 3. Notice it's the exact same equation that's here, only without the absolute value signs. And then we have to write a second equation where we've done two things. The left side stays exactly the same. The sign is going to flip. Here it's greater than, here it's going to be less than, and then we are going to go with the opposite of this number. Up here it's positive 3, so down here we're going to make it negative 3. And then all you need to do is solve both of these individually. So you don't have to combine them together. You just have to solve each one individually and get two separate numbers. So let's see how this looks on paper. Let me pull this up here. Okay, so here we have x plus 9. The absolute value of x plus 9 is greater than 3. That was the problem I just discussed, but I'm going to show you how to do it on paper. So you're going to split it up into two separate sides. I put the line down here just to separate them. On the first one, you are going to write the left side exactly as is, only without the absolute value. So we have x plus 9. And we just copy the entire rest of the problem exactly how it is up here, only without the absolute value signs. On the right side, we write x plus 9. Left side of the equation doesn't change. It's x plus 9 on both sides. And the part that's going to change is here we have greater than. So on the second inequality, we're going to put less than. And here we have positive 3. So we're going to do the opposite and put negative 3. All right, now we have two separate inequalities here, and we are going to solve both of them. Now we're going to solve both of them the same way, but we're going to end up with different numbers. So it's a positive 9, so we need to subtract 9 from both sides. These 9s will cancel out, just leaving our x. The sign's going to stay the same. And then 3 minus 9 is negative 6. So that's going to be 1. And then again, same thing, it's positive 9, so we have to subtract 9 from both sides. And these 9s will cancel out, plus 9 minus 9, leaving just the x. This time it's a less than sign. And -3 minus 9, if you have the same sign, you just add them together, 9, 10, 11, 12, and you keep the sign. So our answer here is x is greater than -6, or x is less than -12. So that is what you would write as your answer on the homework for this one. Like I said, this exact problem is in your homework. Just to show you how this would be graphed, since it's just a greater than and just the less than, it's not or equal to, they are going to be open circles, and you put those open circles on the two numbers that are given, and you're going to have arrows that point opposite directions. All right, so this one we see it was the absolute value is greater than, so on this one it's the absolute value is less than. So just like this first one that we did where the absolute value was less than 3, this one's going to end up looking the same way. Here we have x minus 5 is less than or greater than 10. So just to recap, this means that x minus 5 can be any number that is less than or equal to 10 spaces from 0. So since it's absolute value, any number that's 10 spaces from 0. So it has to be less than or equal to 10 and greater than or equal to -10. So again, when we split this up, these are the two things that we are going to write. The x minus 5 is less than or equal to 10 or greater than or equal to -10. We write this out as two separate inequalities. Here they are. And then, of course, we solve them individually. All right, I'm going to go ahead and get that written down on our pad here. So we have x minus 5, absolute value of that is less than or equal to 10. All right, so let's take a look at what that looks like on paper. So here we have x minus 5 is less than or equal to 10. So what we need to do is, like we did on the last one, split this up into two separate equations. The first one will look exactly like this, only without the absolute value sign. So we have x minus 5 is less than or equal to 10. On this side, the left side of the inequality is going to look exactly the same, only without the absolute value sign. So we have x minus 5. And then we need to flip this sign. It's less than or equal to up here, so it's going to be greater than or equal to here. And then we do the opposite of the number here. So here the number is 10. It now becomes -10. All right, now we just need to solve each one of these individually, and again, we'll solve them the exact same way, but we will end up with different numbers. So this is minus 5, so we need to add 5 to both sides. These will cancel, leaving us x is less than or equal to 10 plus 5 is 15. So same thing on this side, got to add 5 to both sides. These will cancel, just leaving us x. This time it's greater than. -10 plus 5 is -5. So here are our two answers. Now, when we write this, since this is going to be an and inequality, again, we use only less than signs, and we write the small number, in this case is -5. Then we write less than or equal to. Make sure you don't forget that part because it's or equal to in all of them. Then we write our variable. We write another less than sign and then write our high number. So this is going to be what your answer will look like, what you need to write in the box. This is x is greater than -5 and x is less than or equal to 15. And this is how that will look on a graph. We are going to have the closed circles because it's or equal to, And we are going to have the closed circles on -5 and 15, and the line is going to be connecting the two of those in the middle. All right. So this is our last slide, and I know it looks like a lot of words, but trust me, these are actually going to be the easiest problems on here. They don't even involve any math. You just need to look for one thing, and that's this number over here is negative. If you see this number over here is negative, then you don't need to do any math on that problem. You just need to recognize whether it's greater than or less than. So if you have an inequality where the absolute value is greater than a negative number, such as this one here, this is the example that's in your homework, 2x minus 7, the absolute value of that, is greater than -1. Your answer is going to be all real numbers, because like we said before, absolute value is always going to be positive because it measures distance from 0, and you can't have a negative distance. So no matter what number you plug in here for x, whether it's 1, 2, 3, 4, 1 million, any negative number, it doesn't matter. Any number you plug in here for x, it's going to result in a positive number. And all positive numbers are greater than all negative numbers. So if you see a negative number over here, you know, and this is greater than that negative number, then you know the answer is all real numbers. So the flip side of that, so this time we have the absolute value is less than a negative number. If you see a negative number here, and it's this absolute value is less than that negative number, your answer is going to be no solution. Because again, no matter what we plug into here, our result is going to be a positive number. And no positive number is less than any negative number. So just to recap these right here, if you see a negative number over here on the opposite of the absolute value sign, you see a negative number here, you immediately know your answer is either going to be all real numbers or no solution. The next thing you have to look at is what this sign is. So if the absolute value is greater than that negative number, then it will be all real numbers. If the absolute value is less than that negative number, then your answer is going to be no solution. Again, both of these inequalities are taken directly from your homework, as is every other inequality that I put on this set of notes. So there's only like 8 questions on your homework, and I already did about 4 or 5 of them for you. So it should be easy enough. Get it done. Try to get it turned in on time. Get it turned in before Monday at, what time does our class start? 11:40. So you have Monday till at 11:40 to get this turned in to receive your 5 points extra credit for turning it in on time. Also, make sure you take a look at the other video and finish 2.5 if you have not done that yet. If not, I will see you all on Monday. Goodbye.